Hello everyone, quality of service. My name is Meet Patel and today we're gonna talk about how quality of service is used in our network. First of all, what is quality of service? Quality of service enables the strategic optimization of network performance for different types of network. Why do we need quality of service? Well, nowadays we operate converged network, which means all our network are carrying voice, data and video content over the same wire. We don't have this separate out there where we used to have networks for phone, one for data, one for video, but everything is residing over the same IP networks in nowadays. Now, when we look in categorizing different traffic in quality of service, I might have web traffic, video traffic, voice over IP traffic, and email traffic. And by categorizing it and identifying different types of traffic, I can then prioritize them and route it differently. So, if I talk about low delay, we have VoIP and video. That will have the highest priority. And for the lower priority, we have like email and web traffic. Now the main thing we have to look forward is documentation. We should document this quality of service priorities and inform our users so that there is no problem tickets on our tables. Example, if someone in our organization is having trouble in surfing Facebook, but unfortunately it has the lower priority. So we have to make sure that this priority is documentation is explained to our users in well and proper manner. Now, what are some ways of categorizing traffic? We have first the best efforts, the integrated services, and the differentiated services. Now, when we deal with the best efforts, there is no quality of service. This is when we don't have any quality of service at all. So just the traffic is just first in and first out. The second type we deal with is integrated services, also known as hard QoS. The idea here is we're gonna make strict bandwidth restrictions. Example, we're gonna set a bandwidth limit for each service, like email service will get 10% of bandwidth and voice over IP should get 50% of bandwidth, like that. In the next, differentiated services, this is also known as soft QoS. In this routers and switches make decisions based on marking and fluctuate traffic if needed. Like if there is no traffic on voice over IP, the bandwidth of the voice over traffic will be sent to the email traffic where the traffic is loaded. When we talk about quality of service, we have different mechanisms that we have to look into it. We have classification, we have marking, we have congestion management, we have congestion avoidance, we have polishing and shaping, and we have link efficiency. Let's talk about classification. In classification, the traffic is placed into different categories. For example, the email class might contain various types of traffic: POP3, IMAP, SMTP, XMAP. The classification does not alter any bits in a frame or packet. Let's talk about marking. Marking alters bits within a frame, cell, or packet, indicates handling of traffic. The network tools make decisions based on marking. Next, we have congestion management. When a device receives traffic faster than it can be transmitted, it buffers the extra traffic until bandwidths become unavailable. It's also called queuing. Queuing algorithm empties the packet in a specified sequence and amount. There are three types of queuing algorithms. First, we have weighted fair queuing, we have low latency queuing, and weighted round robin. Let's talk about congestion avoidance. Congestion avoidance is when a newly arriving packet will be discarded if the device output queues fill to capacity. Example, if it is a TCP traffic, it will be retransmitted. If UDP, it simply gets dropped. Let's talk about polishing and shaping. First, we talk about polishing. In polishing, it typically discards packets that exceed a configured rate limit. Drop packets result in retransmission and recommended for higher speed interface, while in shaping, buffers traffic exceeding configured rate. It is recommended for slower speed interference. Next, we have link efficiency. is when a packet payload is compressed to conserve bandwidth. Why is it important to have quality of service? There are three causes if we don't have quality of service. The first is delay, we have jitter, and we have drops. Let's talk about delay. When we look at delay, this is when a packet travels from source to destination. This is measured in milliseconds. When we talk about jitter, is an uneven arrival of packet. It is especially harmful in VoIP. When we talk about drops, it occurs during link congestion, router interface queue overflow, and causes packet loss. Now, due to these causes, there is a great impact on availability in our network because these causes can become a major problem in our network. Now let's see some basic setup of quality of service. Here we can see the bandwidth we can assign to the quality of service. Here we have the quality of service rules, quality of service by service, quality of service by device. It's like in a network we have many devices, we can choose a particular device and give him priority. We have application based quality of service. We can choose an application here and we can assign a priority. We have Q1, Q2, Q3, Q4. The Q1 has the highest, Q2 has the high, Q3 has the normal, and Q4 has the low priority. So according to our needs and in our policy, we can easily assign a priority to particular network in our organization. I hope you like the information of quality of service. Thank you and stay safe.